thermodynamically unstable chemical reaction, and it actually is exergonic. What I could tell you is that I have a genie in here, and that's what I would tell you. I have a genie in there. Anybody want to see the genie? What do you have to do to see the genie?
Rub the lamp.
Rub it. Rub it. Rub it. Rub it. All right, so. Woo! Dang. All right. 3 wishes. Are we ready? All right. Come on.
Unlimited wishes.
Anybody get there? She's gone. Nobody said the wishes. All right. Well, maybe next time. I'll bring another genie next time.
Yeah, I can smell it.
Not really. Feel it. Now trust me, it wasn't that warm. Well, now that's a 50-cent question. That'll get you $1. What was in there? Well, I'll show you what was in there. This is the kind of important bit. One second, and we'll write it up. So, the chemical reaction was happening the entire time we were here. Absolutely the entire time we were here. And it's the chemical reaction of what the very next slide tells us. This slide right here, that's hydrogen peroxide. So I had a 30% solution of hydrogen peroxide. When you go to the store and buy hydrogen peroxide, you soak your little, earrings and tongue ring and whatever else ring to disinfect it. Okay, bless you. When you buy that, it's usually a 3% solution. Ours was a 30% solution. So it had a little bit more hydrogen peroxide, like 10 times what you can buy at the store. Now, hydrogen peroxide is not a stable compound. It decomposes over time, all the time, which is if you go to the grocery store or the pharmacy and buy some hydrogen peroxide, you'll note there's a little vent drilled into the cap, a little hole drilled into the cap. That's because the decomposition of hydrogen peroxide turns into water and oxygen. Is this chemically balanced? It's not, is it? So let's chemically balance it. 2 hydrogen peroxides will go to 2 of these, and that's going to leave a couple oxygen atoms, which can form an oxygen molecule. Now this is a gas. It turns out that this reaction, if we speed it up, now what we did, catalysts, I'm sorry for keeping you a second extra, but I'm gonna. Catalysts cut the hill up. They take the peak off the mountain. Catalysts lower this barrier to activation energy. And so in liver, there's a biological enzyme called, what is it? Hydrogen peroxidase is what it is, or peroxidase. Now that peroxidase catalytically does what we did. I used an inorganic catalyst called manganese dioxide, MnO2. It was a solid. And what you didn't see was I had it wrapped up in a little tissue hanging underneath the cork. And so when I pulled the cork, even though this reaction was occurring, it was occurring at a really slow rate because it had a high activation energy. Now as soon as I pull the cork and I let that manganese dioxide drop into the hydrogen peroxide, guess what? The hill has been conquered. And we let, you didn't get to check this out. What would you say? Still rather warm? Yeah, all of you people in the front row, get a hand warmer. All of you people, don't you wish you were in the front row? All right. Good. All right, so what did we do? We added the catalyst. The catalyst increases rate of reaction so fast, and it's an exergic reaction, that this water, a lot of it, boiled. It turned to gas. And so we ended up with hydrogen peroxide turning into water and oxygen, gas. What was this cloud then? It was water vapor. It's not going to be oxygen. Why? Can't see oxygen. But you can see condensing water. And so what it was a gas phase in here, but then it hit the cool atmosphere, right? And it started recondensing into a cloud. And so that's what we saw. The genie was actually a cloud of water vapor.
Why did it get hot?